Welcome to this tutorial about the AI for You Experiments Sudoku Hello World tutorial. My name is Peter Schüller and I will show how to build, onboard, deploy and run this tutorial example. The AI for You Experiments platforms has the aim to provide everyone with the possibility to assemble and run AI solutions. The audience, the intended audience of this video are developers that want to bring their assets into the platform. But if you just want to run a solution that is already in the platform, you can fast forward to the deploy and run section of this video. What is the Sudoku Hello World? It is a simple Hello World example of an AI for You experiment. The purpose is to show how to use the platform. The example is open source and it is in the public domain. So you can use it as a template for your own solutions, for your own components, or you can reuse parts of it. And there is a cheat sheet available, which contains all the steps and commands that I will execute in this video. It is below this video in the description, and it is also in the repository, in the Git repository. The presentation that you see at the moment is also in the Git repository. The user interface of the Sudoku Hello World shows a status text on top that gives some hints what you can do, and a Sudoku field below. Question mark means it is not clear which number should go into that field. You can click on a field and set the field to a certain number, then this number has to go into that field. If you do this, an AI method in the background computes a partial solution and shows this partial solution with the blue numbers. It shows a full solution if there is a unique full solution, but here on top we can see Sudoku has multiple solutions. It shows also if there is no solution, as in this example. It shows a conflict if no solution exists, which means if you change this number that is red, then there can be a solution. In this example, the 2 is a conflict because in this field, the 2 must be in the middle. Why must it be in the middle? Because this field is missing the numbers 6 and 7, and 6 and 7 are already blocked in this column. So the 6 and 7 cannot be in this column. They must be in this field, and they could be in this field with the 2. But then the 2 has to be in the middle. If you want to set a number to a question mark, you click on it, and you click on the same number. Then it becomes a question mark. What are the components the Sudoku tutorial consists of? There is a user interface, the Sudoku GUI. This sends an evaluation request to the design evaluator component. The design evaluator component creates an answer set program that is sent to an aspsolver. The aspsolver sends back answer sets. The design evaluator takes these answer sets and transforms them into information to the graphical user interface and sends back a Sudoku evaluation result. How does this look more on the low level? We have the following services. The user interface has the evaluation request service. This creates the request. The design evaluator has the job preparer service, which creates the aspsolver job. The aspsolver just contains the generic aspsolver service, and this service can also be used in other solutions. Whenever you need to compute the answer sets of an ASP program, you can use this service because it has a generic interface. The aspsolver sends back answer sets. This goes into the ASP result interpreter service of the design evaluator component, and this one sends back the design evaluation result to the result displayer service of the graphical user interface. You can see that the requests go in one line, first down to the right and then up. How does this look in the protobuf syntax? AI for You experiments platform uses protobuf to define the interfaces. Here we see the graphical user interface service with 2 RPC calls, request Sudoku evaluation with an empty input and Sudoku design evaluation job output. Then the process evaluation result service, which is at the end of the pipeline. The design evaluator is a separate service with 2 RPC calls, and the aspsolver is one service with 1 RPC call. If we assemble this solution, I will show this later in detail, it looks like that. We have the user interface which is connected downwards, the Sudoku design evaluator is connected again downwards, and the aspsolver is connected upwards, and the design evaluator is again connected upwards to the graphical user interface. What do you need? For building and onboarding, you need Git, you need to clone this repository that is on the slide, you need Python, and you need Docker. For deploying and running, you need again Python and a Kubernetes environment. For example, Minikube, which can be installed on Linux, Windows, and Macintosh. I will here show how to do it with Minikube. But if you have another Kubernetes environment, that will also work perfectly well. First of all, we need to configure the Docker repository in the script helper.py. So here we use the internal repository of the AI4U experiments. This is possible to get an account for this if you are part of the project. So if you think that you should get an account, please contact Martin Wells. We need to configure the repository, log into the repository, and then we build 3 Docker images and push them to the repository. I will now show these steps in the shell. Here you can see the checked out repository, including a helper.py script. Let's look into that script. The script contains at the top metadata about the components of this example, the GUI in version 1.4, the evaluator in version 1.4, and the aspsolver in version 1.1. And here in line 30 we see the configured repository. I have already logged into the repository, so now we build it and then we tag and push it. We build it. This is very fast because everything is cached because I did it before. Now we tag and push the images. This is also fast because I already pushed the images, so this is cached. If you do this and it fails, just retry. Eventually it will work. Note the red output, which gives an indication what to use for the onboarding. The server, port, the image, and the tag for each of the 3 components. Now let's do the onboarding. For that, we go to the AI4U experiments platform. This is the pre-prod platform because it currently contains the functionality that will be in the live platform. You will of course use the live platform. I sign in and then I go onboarding model. First I show the slide, onboarding. You sign in, you choose onboarding, and for each component you enter model name, host, port, path, tag, then you upload the protobuf file and then you wait until the status is green before uploading the next component. This is important. At this point I want to give a small remark about the orchestrator. In the Git repository there is a directory orchestrator. This is useful for developing the whole solution. It can also be useful for you, but it does not need to be onboarded, or it cannot be onboarded because it is not a Docker image. And this orchestrator is also not the orchestrator that is used for executing, for running the pipeline when it's deployed from the AI4U experiments platform. The platform will automatically add an orchestrator to the solution if the solution contains more than 1 component, and you can also see that orchestrator source code in the Git repository that is shown on the slide. So if you want to improve the orchestrator or extend it, you have a chance to do that. Another remark is about Docker Hub. You can use Docker Hub with AI4U experiments, but you need to omit the server name and the port when you configure the helper.py script. You need to log in without specifying a server name. And when you do onboarding for the host, you use hub.docker.com and the port must stay empty, otherwise it will not work. But if it stays empty, deployment should work just fine. I clicked on onboarding model. Now we enter. So let's start with the GUI. enter this information, and then we browse for the protobuf file, which is in the AI for you Sudoku example in the GUI subdirectory sudoku-gui.proto. Now, very important, click upload. Although it shows here, if you don't click upload, it will not work. Now we click onboard. And now we wait until these icons here become green. Now it is green, and now to onboard the next model, don't enter the data here. Your data will be lost. We first need to click upload new. Now we onboard the design evaluator. With the correct version. Again, protobuf file, this time it's in the evaluator directory, Sudoku design evaluator.proto. This upload button doesn't work. What do? We click X here, we try again, we click upload, and we click onboard. And again, we wait around 30 seconds until this becomes green. I also fast forwarded this, upload new, aspsolver is missing, no, this is the wrong version, 1.1. We can check here the output of the build tag and push script, 1.1. We need another protobuf file, asp.proto. Again, the upload button didn't work, but there is a workaround. We click onboarding. Now we go to the next step. Let's look at the slides. We have to configure the onboarded models. We choose My Models on the left, and for each model we click Manage My Model, Publish to Marketplace, Model Category, and then we select Data Transformer and Scikit-learn. The reason for this is that we cannot see the components in the Design Studio otherwise, and actually it does not really matter which category you choose, but for this example we choose Data Transformer and Scikit-learn. My Models. We choose a model. Let's choose the Sudoku GUI. Manage My Model. Publish to Marketplace. Model Category. Data Transformer. Scikit-learn. This is done. The GUI is now in the first place because it's most recently updated. Design Evaluator, Manage Model, Publish to Marketplace, Model Category, Data Transformer, Scikit-learn, OK, and a third time for the aspsolver. And we have configured our components. The next step is to assemble our solution in the Design Studio. So we next go to Design Studio and launch Accu Compose. We drag all the components to the canvas and connect the matching ports. The matching ports are indicated in the web interface. Input ports have white background, output ports have black background. And we need to save and validate the solution. We click Design Studio, we launch Accu Compose. We see here our data transform tools. If you choose another category, it will be in these folders above or below. We drag the user interface, the design evaluator, and the aspsolver to the canvas. we connect. You can see here the input port of the process solver result can be connected to this port that have the same symbol. The output of the aspsolver goes into this. Just ignore the auto routing. We will fix this problem later. Now we can see the Sudoku design evaluator has an output that goes into the input of the aspsolver, and the output of the aspsolver goes back into the Sudoku design evaluator, into the method process solver result. We also connect the user interface. Now we save the solution. We enter a solution name and some version, and we say validate. Without validating, it cannot be deployed. It is valid, that is fine. Now the Sudoku solution is available here, and if you click My Models, the Sudoku solution is also available here and can be shared like a component with other people or published. Now we go back to the Design Studio and load our Sudoku solution that is at the bottom right here by clicking on it. How do we deploy? First, we need to get the solution.zip. We get this in Accu Compose. We click Deploy, Deploy to Local, Export to Local, and Download Solution Package. We store the zip file to a new folder because it unpacks into the same folder, and then we unzip the file. So in Accu Compose, when we have loaded the solution, we click Deploy, Deploy to Local, Export to Local, Download Solution Package, and we have solution zip here. I downloaded solution zip into this folder. I unzip it. Now we see a few files here. As I said, we need some Kubernetes environment. In this example, we will use Minikube. First, we need to create a new namespace for the example. Here we call this namespace Sudoku. You can choose any name because you can give in each command that will follow, you will need to give this namespace as a parameter. Once we have the namespace, we run the deployment script, and then we write down or we save the end of the output. I create the namespace Sudoku. I run the Kubernetes client script, and it tells me I need to specify the namespace. I specify the namespace, and I have here at the end of the script a node IP address and an orchestrator port. We use this IP address and the orchestrator port to run the orchestrator, which is in a subdirectory. And this shows a failure. We see that this does not work. So let's inspect the Kubernetes environment with the following command. We show the services and the pods of this environment, and we see the status of the pods is image pull backup. It cannot get the image from the registry. To check out why this is the case, we can look at the events that happen. Kube describe, namespace, pod, and then one of these pod names. It shows which image it tries to pull and what are the errors. In my case, I repeat to query this, and I see that already 2 of the 4 pods are running. The problem was that I was behind a firewall that somehow blocked the access. So I used the VPN, and now I get the images. And note that pushing to that Docker registry was no problem. But pulling from the Docker registry somehow seems to be a problem. I will now just use the watch command to continuously observe what is happening. And after 8 minutes, finally, we have all images running. Now we again try to start the orchestrator. We start the orchestrator client. The orchestrator client connects to one of the images and starts the orchestrator. And now we see that nothing happens, because the orchestrator runs and waits for some input. But we need to give the input using the graphical user interface. In our deployment, how do we access the graphical user interface? If we are using Minikube on Windows or Mac OS, it's a bit more complicated than if we use it on a native Linux system, if we are on the same host. How we do it in general, this works on both variations. We call Minikube the namespace, service, URL, and then Sudoku GUI1 web UI. And this command gives us a URL that we can give into the browser to access the web interface. So this tunnels the browser directly into the Kubernetes environment, into the right service. If we are on the same host, we can just use the command I used before for debugging, get node service pod output wide. This shows us an IP address of the node and the port of the Sudoku GUI web UI, and we can just directly enter this. We don't need a tunnel. So I'm opening a second shell. And I run this command, and it gives me a URI. This URI I enter into the browser. And I see the Sudoku GUI. Now in this GUI, we click a field and select a number. And we see something has changed. This is already the result of running the pipeline once. We fixed this number and we got a partial solution for this Sudoku. If we click again, nothing happens, except that the solution is deleted. Why? Because the orchestrator did run only once. We see here the orchestrator has finished processing. So let's run the orchestrator in a loop. This is just a loop that we can interrupt with Ctrl+C. And we can see the orchestrator has already done its job another time. Now we can set other numbers. Now we see there is no solution and we have a red 6 here. Why? Because we have to change, for example, this 6 to get a solution. Why is there no solution? Because there is a 6 in the same row. If we change this 6 to a 5, we get another conflict. Now with this 5. So let's choose 4 and we get a partial solution. And I'm very good at choosing conflicts at the moment. Now the Sudoku runs in the Kubernetes cluster in the Minikube, and it is orchestrated, and it was deployed from the AI4U experiments platform. This slide explains how to test the Sudoku and how to run the endless loop of the orchestrator client. As final comments, I want to say this is the status of the March 2021 release. The easiest way to run and deploy this is Minikube on a native Ubuntu long-term support version, for example 20.04. And this demo was created with Minikube in the Windows subsystem for Linux version 2. And I installed Docker within the Windows subsystem for Linux, not Docker desktop. And I installed Minikube within the Windows subsystem for Linux, not the Windows installer. This seems to be important. I could not get it to run in another way. But I will be glad if one of you tells me how to do it with Docker Desktop and Minikube on Windows. I'm sure it should be possible. If you have any feedback or questions, please contact me on the email address. Thank you for your attention.